In this next recording, I'm going to share once again some very fundamental basic information on how an action potential actually begins and what happens as a result of it. So it actually starts with the top picture, which shows those dendrites going to the cell body. As it turns out, there's actually within that neuron, and any neuron, there's kind of a barrier between the inside of the neuron and the outside. If you look at this picture where it has outside the cell and inside the cell, it's a picture actually called the lipid bilayer. Separating the outside part of the cell and the inside of the cell is a lipid bilayer. That's the wall basically from outside to inside. And if you look at it, there are little protein channels and other channels kind of going through there. There are three important things to know about the neuron before anything happens to it. And by the way, we call the neuron before anything happens to it. That's considered the neuron in its resting state. So the neuron in its resting state is what's going on in the neuron before anything occurs electrically. So in the resting state, what we basically find are a couple of interesting things. First of all, if we actually take an electrode and measure outside the neuron versus inside the neuron, we'd actually find that there's a difference in the charge during the resting state. It turns out that inside the neuron, the charge is negative 70 millivolts compared to outside the neuron. So the first fun fact, if you will, is that inside the neuron, the charge is negative 70 compared to outside the neuron. The second thing that we know about the neuron is that there's a lot more sodium, Na+, outside the neuron, and there's a lot more potassium inside the neuron. So those are the other two things we know as well. And finally, and I should add this as the next fact here, if you're sodium, you'd kind of want to diffuse inside the neuron, and if you're potassium, you'd kind of want to go out to kind of balance yourself out. But it turns out that there's a element in there, and it's actually called the sodium-potassium pump. And the sodium-potassium pump keeps more sodium outside and keeps more potassium inside. So those are the fun facts about a neuron during the resting state. And your book probably has more information, obviously, as well. So the next thing to know is, okay, if a neuron is starting like this during the resting state, what actually has to happen to start an action potential? And here, you actually have to go back to the very first picture with the dendrites. The thing that must occur is if you look at those dendrites, they almost look like little branches on a tree. And they actually are branches on a tree in a way. What actually has to happen is when something comes into your system, when a signal comes in or when you look at something, those dendrites have to collect 15 millivolts of positive energy. That's 15 millivolts of positive energy. So if you have three little dendrites in there and one collects 5 millivolts of positive energy and a second one does and then a third one does, that energy, the 5, 5, and 5, it'll all summate in the cell body and it'll start an action potential. So a couple of other terms you need to know. Instead of saying 15 millivolts of positive energy, we have a better term for that. We call it 15 millivolts of depolarization. That means going towards zero, and that's what depolarization means. So if the dendrites collect a total of 15 millivolts of depolarization, it'll summate at the cell body. Now, if you only get 14 millivolts, there'll be no action potential. Because in order to start an action potential, you have to reach that 15 millivolts of depolarization because that is a threshold value. You have to reach that threshold. If you don't reach the threshold, no signal will be sent. So 15 millivolts of depolarization must be achieved in the cell body, and if you get that, that will actually start an action potential. So hopefully you understand that particular idea. Now the next step, once you actually start an action potential, is once again to look at that first picture again. A signal will actually be sent out on the axon. And if you look at that picture, it looks like that electrical signal is being sent all the way down the axon. And that is actually correct. It's sent down the axon kind of from point to point. Those little points are called, as the drawing says, the nodes of Ranvier. Basically, the action potential is recreated at each one of those points. And by being recreated at each point, the myelin sheath that insulates the neuron, the axon at that point, kind of sends the signal faster and faster down the axon. So the myelin sheath is there. If your myelin sheath isn't working right, that can lead to multiple sclerosis. So basically, for this electrical event to happen, the dendrites have to collect 15 millivolts of depolarization. That will summate at the cell body, and if you get the 15 millivolts, that will lead to an action potential starting. That signal will be sent down the axon. It's actually given a name. I'm sorry I didn't write the name in. The name of that process is called saltatory conduction, SALTATORY. It's called saltatory conduction, which basically means down the nodes of Ranvier, point to point to point, all the way to the end of the axon. So hopefully that makes sense and you understand that. Thank you. Bye-bye.